Hello friends, myself Muhammad Ashraf Khan, and today I am going to explain you how to calculate oxidation number. Here are some examples for you. For the first one is carbon dioxide. We have to find the oxidation number of underlying atoms. Like here we have to find the oxidation number CO2. In this one also we are going to find the oxidation number of carbon. Here also for carbon. In this ammonium sulfate we have to find the oxidation number of nitrogen. In Pb3O4 oxidation number of lead. Let's start with CO2. Suppose the oxidation number of carbon is X. Then we put plus sign, then we write this subscript 2 here, then we use bracket. What is the oxidation number of oxygen? Generally it is 2. Okay, the sum of oxidation number of all the atoms is always equal to 0. So here X minus 4 is equal to 0. So we can say X is equal to plus 4. So the oxidation number of carbon in carbon dioxide gas is plus 4. The next example is CH2Cl2. This is called methylene chloride. This one I suppose X, then plus, then we write the subscript. The oxidation number of hydrogen is plus 1. Then again we have to put first plus sign, then we have to write the subscript. Then what is the oxidation number of chlorine? Generally it is minus 1. The sum of all the oxidation number must be equal to 0 for a molecule. So this is a molecule. So here X plus 2 and minus 2 is equal to 0, and X must be equal to 0. So here the oxidation number of carbon is 0. In CO2 oxidation number of carbon is plus 4. Now the next one is CH4. Assume oxidation number of carbon is X, then we put plus sign, we write first subscript, then oxidation number of hydrogen is assumed to be plus 1. It is always most of the time it is plus 1, but in case of metals, when hydrogen is combined with metals, then it is called hydride, and the oxidation number of hydride is minus 1. The sum of this oxidation number must be equal to 0. So X plus 4 is equal to 0. So X is equal to minus 4. In this one also you can calculate X, then we add plus. Okay, we write first subscript, then minus 1 for chlorine. Sum must be equal to 0. This one will become X minus 4 is equal to 0. We can say X is equal to plus 4. So students, I hope you learned already. You understood that the oxidation number of carbon varies from minus 4 to plus 4. It can be 0 also. Now we have to find the oxidation number of nitrogen. Okay, this is ammonium sulfate. So for nitrogen, student, we can solve this one in 2 ways. We can split into ions also. The ion which are formed by the dissociation of ammonium sulfate is ammonium plus 1 ion, and the another one is sulfate 2 minus ion. Okay, this is ammonium plus 1 ion and sulfate is minus 2. So with the help of this ion we can find the oxidation number of nitrogen. So nitrogen oxidation number NH4 plus ion. Here for nitrogen I write X, then I write plus, then we have to write subscript first. What is the oxidation number of hydrogen? Plus 1. For ion, the total oxidation number is not equal to 0. It is always equal to the charge which is present on the ion. So here charge is plus 1. So here the sum of all the oxidation number must be equal to plus 1. Now you can solve it easily. So X plus 4 is equal to plus 1. So x plus 4 is equal to plus 1. So X will be equal to minus 3. Answer. I hope you understood. Thank you. The next one is Pb3O4. Pb3O4 is actually a combination of two oxide of lead, 2 molecule of PbO and 1 molecule of PbO2. So 2 Pb, here 1 Pb. Total how many Pb? Pb3. And how many oxygen? 2 oxygen here, 2 oxygen here. Total how many oxygen? 4. So this is the actual form of Pb3O4. But in combined form we write Pb3O4, not like PbO.PbO2. We can write it in this way also, PbO plus PbO2. Okay, it's the same thing. If we have to find oxidation number of Pb, this is called average oxidation number. Average oxidation number of Pb. Then what it will be? Then we have to write the subscript first, which is 3. Then assume the oxidation number of Pb is X. Then we write plus sign. We have to write the subscript. Oxidation number of oxygen is minus 2. This all become to 0. Is all equal to 0. So 3x. This one will become minus 8. And if I transfer minus 8 to this side, it will be 8. Then x will be equal to plus 8 divided by 3. Means on 3 Pb there is total charge plus 8. Okay. The next one is Na3PO4. In this one we have to write oxidation number, or we have to find the oxidation number of sodium. Sodium here subscript is 3. We have to write subscript first. Oxidation number of sodium we don't know, that's why we write for this one it is better to find oxidation number of phosphorus, because sodium is always plus 1. So there is no need to find oxidation number of sodium. We have to find for phosphorus. Here sodium 3, oxidation number of sodium is always plus 1. Okay, then we write plus. For phosphorus we don't know, then again we write plus. Oxidation number of oxygen we already know, minus 2, but we have to write 4 first, then minus 2. The total of all these oxidation number is equal to 0, because this is a molecule. This one becomes plus 3 plus x. 4 minus 2 will be equal to minus 8, equal to 0. Okay, so plus 3 minus 8, it is minus 5. If the minus 5 goes to the other hand side, x will be equal to plus 5. So the oxidation number of phosphorus in sodium phosphate is plus 5. Now the next problem is NO3. Is it clear, student? NO3. NO3 is an ion. So the total oxidation number is not equal to 0. Okay, the oxidation number is equal to the charge which is present on this ion. Okay, please remember this thing. This one is very important. For nitrogen, again we follow the same procedure. X, then we write plus. The subscript is 3. What about oxygen? It is minus 2. The sum of all the oxidation number must be equal to the charge present on this ion. So here x, 3 to the 6, become minus 6 is equal to minus 1. X will be equal to, if I transfer minus 6 here, it will become plus 6. Plus 6 minus 1 plus 5. Answer. Okay, the nitrogen here is in plus 5 oxidation state. Okay, and the next one is perchlorate ion. For chlorine we can write x, then write plus, then subscript. Oxidation number of oxygen is minus 2. The sum must be equal to minus 1. X multiply this one, minus 1 is equal to minus 1. The x will be equal to plus 7. So here in perchlorate ion, oxidation number of chlorine is how much? Plus 7. Okay students, now we have to find the oxidation number of chromium in this dichromate ion. This is called dichromate ion. Okay, here we write subscript first. Okay, then we write oxidation number of chromium, which we don't know, so we have to write x here. Then we have to put plus sign, write subscript again. oxidation number of oxygen again. Now the sum of oxidation number is not 0 here because it is an ion, so it must be equal to the charge present on this ion. It is -2 in this case. So 2x, 7 minus 2 will be -14 is equal to -2. Then x will be equal to 14 when go to right hand side, and -2 it will become +12. This +12 when divided by 2 it will become +6. Is it clear? Okay, so 2x when equal to +12, so 2 will go in denominator and you will get x is equal to +6. So the oxidation number of chromium here is +6. Now the next example is potassium ozonide. This is called potassium ozonide. Oxidation number of oxygen in ozonide is always -1/3. Let's find what is the oxidation number of oxygen here. So potassium, we know already that it is always +1. Now we have to put plus sign, then write subscript. Oxidation number of oxygen we don't know. Okay, so I write x here. The total must be equal to 0. We can say that 3x +1, when we transfer +1 from left hand side to right hand side, it will become -1. Then x will be equal to -1/3. Students, I think you got my point. In ozonides, the oxidation number of oxygen is -1/3. This is per oxide, potassium per oxide. Okay, in case of peroxide, what is the oxidation number of oxygen? That we know already. This is not peroxide, this is superoxide. Okay, this is actually superoxide. So in superoxide, we already know that oxidation number of oxygen is -1/2. Let's find it. The potassium, for potassium it is oxidation number is +1, then again write 2, then we have to write subscript. Oxidation number of oxygen we don't know, that's why we write x. The sum must be equal to 0. So here +1 plus 2 into x will be 2x is equal to 0. Then 2x will be equal to +1. When go to the other hand side, -1. So x will be equal to -1/2. Is it clear, students? So this is superoxide. When oxidation number of oxygen is -1/2, then it is called superoxide. This example, okay, I explain you this one also first. This is iron. We have to find the oxidation number of iron. In this case, students, we have to write oxidation number of potassium first. Here potassium is 4, write first 4 in subscript. Oxidation number of potassium is +1, we write +1, then we write again plus. Fe we don't know. Okay, about cyanide ion, again we write plus, then we write 6 first. What is the oxidation number of cyanide ion? It is always -1. The total must be equal to 0. So if I solve, +4 plus x -6 is equal to 0, then x will be equal to +2. Answer. Okay, so here oxidation number of iron. The next example is metal carbonyls. This is nickel tetracarbonyl, this is iron pentacarbonyl, this is chromium hexacarbonyl. Students, remember that in metal carbonyls, oxidation number of metals is always 0. This is a special case. This CO is carbon monoxide. The carbon monoxide oxidation number is always equal to 0. Okay, if I write x here, then write plus, then write subscript. The oxidation number of CO means carbon monoxide is 0. Total must be equal to 0. The x plus 0 is equal to 0. The oxidation number of nickel will be equal to 0. Similarly here and here also for iron and chromium. So in case of metal carbonyls, means when metal combined with carbon monoxide, the oxidation number of metal is always 0. So here is 0 and here is also 0. Okay, now the next example is CrO5. Students, this one is a very good example. We have to find oxidation number of chromium. Here from this formula you can find oxidation number in this way. Okay, X for chromium, 5 subscript for oxygen -1 equal to 0, then X minus 10 equal to 0, X will be equal to plus 10. This is totally wrong. Okay, chromium oxidation number is, maximum oxidation number is +6, but here in this example if you find +10 then it is totally wrong. Then how to find the oxidation number of chromium in chromium pentaoxide? So we have to draw the structure first. For this one, so we write this is single atom. Single atom we always write in the center. Now we have to write 5 oxygen. So 1 oxygen, 2 oxygen, 3 oxygen and 4. The last one I will place later. They all must be bonded to chromium because it is a molecule, and 1 oxygen I write here and must be bonded with single bond. So these all are 5 oxygen. This is chromium. Now I know that chromium can form maximum 6 bond and its maximum oxidation number is +6. But for oxygen form at least 2 bonds. Students, how many bonds? 2 bonds. But here oxygen have only 1 bond. Here oxygen have only 1 bond. This one 1, this one also 1. If I write 1 bond here and I write 1 bond here, then oxygen is satisfied, means oxygen got 2 bonds. This one also satisfied, it got 2 bonds. This one 2 bonds, this one 2 bonds. Okay, what about chromium? 1 2 3 4 5. 1 bond is remaining. So I write 1 bond here. Now this oxygen is also having what? 2 bonds, and chromium having maximum 6 bonds. So this is the structure of chromium. Now this oxygen is called oxide. So oxide have -2. This oxygen when combined with another oxygen, these 2 oxygen and these 2 oxygen are called peroxide. So oxidation number of peroxide is -1. This one also -1, this one also -1, and this one is also -1. The total oxidation number on oxygen is -1, -1, -1, -1, total -4, and -2, -6. The total is -6. On this oxygen, the chromium oxidation number will be +6. Now our answer is correct because chromium maximum oxidation number is +6. Okay, now this one Br3O8. We have to find this one also, the oxidation number of bromium here with the help of formula. So this one I tell you later. I will draw the structure of this one later. What about H2SO4? We have to find the oxidation number of sulfur here. Okay, how many hydrogen here? 2. So we write 2 in here first. Oxidation number of hydrogen is +1. Then plus sulfur oxidation number we don't know, so I write plus here. How many oxygen? 4. Oxidation number of oxygen is -2. Total must be equal to 0. So this one is +2, this one is X, this one will be, this one will be 4 to the -8 is equal to 0. The X will be equal to +6. Okay students, but here if you try to find sulfur oxidation number, how much it will be? Here 2 plus 1, sulfur is X, 5, oxygen -2 is equal to 0. This will be +2 plus X minus 10 is equal to 0. X will be is equal to +8. This answer is totally wrong because I told you in last lecture the maximum oxidation number of sulfur is +6. If it comes +8, then this one is wrong. Then what we will do? Then we have to write the formula, the structural formula for this one. Okay, now I write sulfur here because this is the single atom. It is called central atom. Now I have to write 5 oxygen first. Okay, I write 4 first. 1 2 3 4. These all are bonded with sulfur, so I write at least 1 bond. The number of hydrogen is 2. The hydrogen is always bonded with oxygen, so I write these 2 here. I can write anywhere. Here also I can write here, but here 2 oxygen. 2 hydrogen. So hydrogen can attach with maximum 2 oxygen. So here hydrogen can form 1 bond, okay. Here also, okay. Oxygen having 2 bond, okay. This oxygen was also bonded with 2 bonds. Now this oxygen at least form 2 bonds, this one also 2 bonds, okay. So valency of oxygen is satisfied. What about sulfur? 1 2 3 4 5 6. So valency of sulfur is also satisfied, because sulfur can form maximum 6 bonds, hydrogen can form maximum of 1 bond. So here this one is the formula of H2SO4. What about H2SO5? Means we have one more oxygen. So where we can put one more oxygen so that the structure remain correct? So what I do, I write oxygen here and then hydrogen here. Now check how many valency of hydrogen here? 1. This oxygen have 2 valency, this oxygen is 2 valency, rest of the things are same. Then now we have to find oxidation number of sulfur. So we write oxidation number of all the other atoms present here. The opposite is the oxidation number sulfur. What about hydrogen? Is +1. What about oxygen? This is oxide, so -2. This one also -2. This oxygen is also -2. But these two oxygen are peroxide. Why? Because oxygen is attached with oxygen, is called peroxide, and peroxide oxidation state is -1. Here also -1. This one is +1. If you total all the oxidation number, it will become -6. Okay. Then the opposite will be the oxidation number of sulfur. So here oxidation number of sulfur is +6. The last one is carbon suboxide. Carbon suboxide means 3 carbon. We have to find the oxidation number of carbon here. Okay student, so we have to draw a structure first. 3 carbon, I write 1 2 3. Okay, they must be bonded with at least 1 bond. How many oxygen here? 2. So I write 2 oxygen here. Oxygen required 2 bond, that's why I formed 2 bond here. As the oxygen is also required 2 bond, I write 2 bond here. Now carbon can form maximum of 4 bond, so I write 1 bond here and 1 bond here. Now this carbon has 4 bonds, okay. This one also 4 bonds, so here also okay. This one also 4 bonds. The carbon valency is satisfied. Oxygen is also having 2 bonds, so everything okay. If any atom is attached with the same atoms, then oxidation number of this one becomes equal to 0. Now what about this oxygen? Oxygen is oxide, so oxidation number of oxide, this one is -2. What about this one? This one is also -2 because this is oxide. The reverse is the oxidation number of this one. This one is +2 and this one is also +2. Is it clear? So oxidation number of these 3 carbons, carbon number 1 is +2, carbon number is 0, and carbon number 3 is +2. What about the average oxidation number? The 3 carbon have total 4 charge, so we can say the average oxidation number of carbon is equal to +4 divided by 3, means total plus charge is divided on 3 carbon. Now I follow the previous procedure here to find the oxidation number. This is average oxidation number, okay. How many carbon? 3, so I write 3 here. Oxidation number of carbon I don't know, I write plus here. Now I write subscript again. Oxidation number of oxygen is -2, total is equal to 0. Okay students, now 3x 2 2s are 4 will be equal to -4, 0. 3x will be equal to +4 and x will be equal to +4 divided by 3. So in this way also I got the oxidation number of carbon. This is average. For different carbon we have oxidation number +2, 0 and +2. I hope you understood, and thank you very much. See you in next lecture.